Okay, so this is part 2 of our rectangles notes. Okay, I'm doing example 4, the coordinate geometry example. It says plot the points A, -1, 0. So here's A. B is at 5, 2. So here's B. C is at 4, 5. So here's C. And D is at -2, 3. Okay, so here are my 4 points. It says determine the type of quadrilateral formed. Okay, so I don't know if it's a rectangle yet. This is what the proving part of it, right? Coordinate geometry, I'm typically proving what it is. Okay, so I want to figure out first, is it a parallelogram, right? So I need to figure out, determine, right? Let's see if our opposite sides are parallel. Determine if opposite sides are parallel. And how I do that is using my slopes. Okay, so let's just take DC, this side right here. It is opposite to AB. Okay, I'm going to find the slope using rise over run on my graph. So if I go from point D to point C, I go up by 1, 2, and to the right, 1, 2, 3, 4, 5, 6. So 2 over 6, which is equivalent to 1/3. If I do from point A to B, the side that it's opposite to go from A to B, I go up 1, 2, to the right, 1, 2, 3, 4, 5, 6. So again, that's 1/3, right? So these two sides are parallel. Now I'm going to do the sides with AD, so DA and CB. Remember, definition of a parallelogram is if both sets of opposite sides are parallel, right? That's all we need to prove if a quadrilateral is a parallelogram, are both pairs of opposite sides parallel. Okay, so if I go from D to A, that's -1, -2, -3, right? If I go down 3, to the right 1. So -3 over 1. If I go from C to B, 1, 2, 3 down, right 1. So -3 over 1. So these two sides are also parallel, right? Parallel lines have the same slopes. They don't all 4 have to have the same slope, but your opposite sides have to have the same slope. So this is good. This is at least a parallelogram, right? So I'm going to put parallelogram. Check. So all the properties that we learned from parallelogram are true with this figure. But now we want to figure out, let's just take it one step further, because now with rectangles, what we've learned is that there's now 4 right angles, okay? And from chapter 3, parallel and perpendicular lines, right angles are formed by perpendicular lines. Okay, so I want to figure out, determine if consecutive sides, not opposite sides, the sides that are right next to each other, are perpendicular. This is going to create the right angles. Remember, we need 4 right angles, right? So if I just want to label my slopes, right? DC had a slope of 1/3. AB had a slope of 1/3. These are the slopes. DA had a slope of -3 over 1. And CB had a slope of -3 over 1. Remember, perpendicular lines, right? Right angles. I need opposite reciprocals. If I take 1/3 and I flip the fraction and change the sign, I should get -3 over 1. Or if I take -3 over 1 and I flip the fraction and change the sign, I should get +1/3. So my consecutive sides, like DA, is adjacent to or consecutive to AB. -3 over 1, 1/3. Those are perpendicular, so there's a right angle. DA is also consecutive to DC. -3 over 1, 1/3. There's another right angle. 1/3, -3 over 1. Those two consecutive sides. -3 over 1, 1/3. So there it is. There's 4 right angles, okay? So this is a rectangle.